And again, as usual, we'll be starting with panelists introducing themselves. So I'd like to start with, okay, Jay has already been here. So Jay, you will be the last. We'll start today with Abhishek. All right, so Abhishek, tell the listeners about you.
Thank you, Deepak, for having me here. My name is Abhishek Khambata. I am a final year mechanical engineering student. Uh, Flying has always fascinated me since childhood, which led me being me being a captain of Team US and MIMS, which develops unmanned aerial vehicles, and a founding member of Team Radiant, which solely works on rockets. So yeah, I have worked both on unmanned aerial vehicles as well as rockets.
Okay, that's amazing. And Sandeep.
Hi Deepak, thank you for giving the chance to be in this webinar, and it's a great pleasure to have you. So I will start with my name is Sandeep Jangid, and I completed my graduation from University of Petroleum and Energy Studies, Dehradun, in year 2019, and I am currently working at Tata Aerospace and Defense as an RF engineer. My passion for these rockets started when I was in college, second year, and when I first worked on CanSat. So that's it about me. Thank you.
Okay, so Jay, I am expecting that if the previous audience is joining us today, they would be obviously knowing you, but still,
Yes.
let's
Oh,
yes
I'll give a
go with
brief
it.
intro about myself. Hello, everyone.
Yeah.
Thank you for joining in. My name is Jay Kamdar. I'm currently pursuing electrical and electronics engineering from Willow Institute of Technology. And I've been deeply interested in space and specifically rockets since my childhood. I have done private rocketry projects as well as I've done an internship at Star Lab Surat, and that's about me. I'm also part of SEDS India, which stands for Students for the Exploration and Development of Space, as an executive director in the board. That's about me.
Okay.
Yes.
So, guys, all the viewers who are joining us currently, I hope now you know your panelists. So now it's time for you to know your moderator. So myself, Deepak Kumar, and I'm currently a physics Q&A expert at Sky.com. And before this, I've been a propulsion engineer in the Department of Propulsion at Space Technology and Aeronautical Rocketry. And apart from this, I'm currently pursuing Integrated Masters of Science in Physics at NIT Surat. Right, so that will be all. And like today, since we are focusing on rocket technology, we'll start with a very basic thing, like how, in very simple terms, like if you had to explain it to a layman, how would you define the term a rocket? Starting with Sandeep.
So rocket is basically a space vehicle which is launched vertically, generally in the towards the sky. So it is uh, it is a space vessel which is used for transportation of various kinds of payloads, which varies from humans, satellites, or some experimental payloads. So it is a controlled explosion which it works on basically Newton's second law of motion. So
Mhm.
that's it. I will define the mechanics behind the rocket.
Okay, and Abhishek.
For me, it's a vehicle used for transporting humans or various satellites or other payloads to space, or anything which takes off vertically from the ground by using its own propellant systems. Uh, and sometimes it may come back or it may orbit around the Earth.
Okay. So quite yes, Jay. Can you like simplify it more? Like
Yes,
just asking.
I can present a different perspective to this. Like the basic
Hmm.
definitions have been already well said by Sandeep and Abhishek. So I see it as like if we observe the history of mankind properly, humans have always had the tendency to explore stuff. Like Christopher Columbus, who sailed around the world and like discovered new places, and the Europeans and everybody. So what they were basically trying to do is explore unseen lands before, like unseen realms. So space is a basically an unseen realm for us now. We are on the verge. We already reached there, but we are still trying to explore it further and further. So rockets are basically the only element that can take us to this realm. They are like our ships to sail the sea or sail the sea or something. Like, you get the analogy, right? So
Yeah, I get it.
yes, so it's very exciting, and like we should. It is basically our future.
Hmm.
That's
Yeah. We are actually living in the future right now, right?
yes.
All right. So,
We have a lot to look
yeah.
forward to.
So for the past few days, for the past few weeks, I've been playing Kerbal Space Program a lot, right? So I have this own definition of rocket from all these explosions, like something that's pointy at one end, and the only good thing is that the pointy end should always stay away from the ground, right?
Yes,
To avoid the explosion. So that's the very first control theory of rocket that says. So
If that pointed thing, yeah, if that pointed thing hits anyone, that
that
becomes a missile,
yeah,
right?
yes,
exactly. Yeah. So you also knowing about the model rocketry, right? So the next question is like, how do you expect, like, how the model rocketry actually helps you learn the concepts of big picture of rocketry? Like I would,
Uh,
okay, let's start with Abhishek.
So before any student starts speaking any language or he starts writing any essay, he needs to know what is an alphabet, right? So in a
Hmm.
similar way, model rockets are the
Yes.
alphabets, and the essays are the big rockets which send you to space. So if you want to
Okay.
learn how a big rocket works, you need to know the small subsystems. So that is how model rocketry helps you in understanding the different concepts like propulsion system, avionics, guidance and control systems, recovery systems, and various other small systems that are actually used in the bigger section. So it's basically an alphabet to an
That
essay.
was really
Um,
yeah, that was really good. Like starting with all the analogy was quite good. And Jay,
all right. So model rocketry is basically a stepping stone into the world of actual rocketry, and they give the hands-on experience to students who don't have access to actually working on the rockets that send us into space. So this is the platform. This is the opportunity. The doing model rocketry is an opportunity where you can learn everything about subsystems of a rocket. How does a team actually assemble and make a rocket from scratch, and all other important stuff that you need to know before you start working on an actual rocket. So I see it as that. And currently, model rocketry is also turning into a new definition. Like if you want to send a actual payload into a suborbital flight, you can use a model rocket. So it becomes an actual mission. It's not just a stepping stone anymore.
yeah.
So I think the entire world is working towards developing more efficient, eco-friendly, as well as cheaper alternatives for launch vehicles that are called small launch vehicles, like basically, which can launch payloads below 100 to
Hmm.
10 kg, in the range of 10 to 100 kgs, basically. So that's what it
Okay.
basically means.
Yeah. Since you've tossed this term small launch vehicles, like I would like to have views of Sandeep on small satellite launch vehicles. Like, what do you think about it?
I will start with giving a reference of the recent space program, which is going to be launched by the ISRO in April 2020. But now, amidst the lockdown, it is being extended. So, so ISRO is
Hmm.
developing a vehicle named as SSLV, Small Satellite Launch Vehicle. So, what it will put the payloads into orbit, having weight of 500 kgs in LEO and 300 kgs in SSO orbits. So what this will do? So I have views on this topic that our future currently depends on the small satellites, because larger satellites are gonna reduce in upcoming years, as many studies suggest, and a study from MIT suggests that in future various constellation of small satellites will be used for various purposes, like for communications, for remote sensing, for Earth observation.
Hmm.
So at that time, these small satellite launch vehicles will pave a path for the future rocket enthusiast. And also, small satellite launch vehicles reduce the cost of commercial launching, launching, and small satellite launch vehicles can be just prepared in 6 days, instead of the longer vessels took months to assemble and integrate. So this is my view on small satellite launch vehicles.
And Abhishek, what do you think
Uh,
about the satellite launch vehicles?
I would simplify it further. Actually, whatever Sandeep told was absolutely correct. I would simplify it further by giving an another analogy. Actually, so if a single person wants to go from one place to another, he might
Hmm.
use a six wheeler car, or a six-seater car, or a two-wheeler, right? So what? So the
Okay.
cheaper option is a bike, because the bike will consume lesser fuel. So
Hmm.
in a similar way, if you are launching a small satellite, you don't want your satellite to go in a big Falcon rocket, right? So that is why small sat launch vehicles are being made, so that we can launch small satellites at a very low price.
Okay. Fine. So, Jay, since you have been working with SEDS, help us get a better insight to this small satellite launch vehicle. I'd like to have your views on it.
Yes, so I think Sandeep and Abhishek had very well drafted answers out to this. Also, we can
Hmm.
take a look into this at an actual perspective, like what is actually going on in the small satellite launch vehicle market. As Sandeep told, we are already developing SSLV. That is a very great venture that ISRO has taken up, and I was hoping that we can also privatize it, as we discussed in our last webinar. Uh,
Hmm.
but around the world, they are working at a much faster pace than us. So we have Rocket Lab's Electron rocket, which is basically kind of a miniaturized version of Falcon 9, we can say, but not exactly.
Yeah. Hmm.
Uh, the thing is, earlier, from 1960s to 2010, like satellites used to be very bulky and chunky, like they were very heavy, and we technically required heavy rockets like Delta 4 Heavy and other rockets by ULA and SpaceX. But now what is happening is
Hmm.
the satellite world is basically revolutionizing. Like we are achieving great feats in areas like nano electronics and stuff like that, which is basically making our satellite smaller, still achieving the same purpose as before. So for usually what happens is when the small satellite market begin to develop, we didn't have enough launch vehicles that were suited to launch them individually. So what they used to do is they used to become piggyback payloads. Now piggyback payloads are like when SpaceX or say SpaceX is launching a huge satellite, these small satellites will stay in the coupling or the fairing and get launched like piggyback their ride to the space. But that's not what ideally should happen. Like
Okay.
we
Hmm.
need individual space launch vehicles for these to allow flexibility in the orbit positioning and the functioning of the satellite. So that's what we are heading into right now. Currently, the aerospace industry is heading towards developing better and reusable launch vehicles. I think a few days ago, Rocket Lab tested the reusability of its booster, which is like what I was expecting since quite a few
Hmm.
years. Because the Electron rocket is, and I think mostly 3D printed and very easily accessible. So it's bringing on a revolution. Like anyone can make a small satellite launch vehicle at a
Hmm.
reasonable cost and launch it. So it's making it available to public. That's 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 all.
Okay. Hmm.
Yes.
So actually, I'm currently getting some doubts regarding the satellite, but I think I'll save it for the next webinar. Right. So, like I've been like since we heard about the Falcon Heavy, then Delta 4, and other heavy launch vehicles and the lifters, the more really the powerful launch vehicles. I would just come to this question like, could you just tell me about your favorite launch vehicles? Like, let's start with Jay.
Okay. Obviously, my favorite launch vehicle is loved all over the world. It's Falcon Heavy because because of many features actually. Falcon Heavy is
Hmm.
currently the most powerful rocket, active powerful rocket after Saturn V,
Hmm.
and it can
Okay.
take up to 60 tons into space, low Earth orbit, and
Hmm.
also like it's pretty considerable. Like if you want to assemble a station, Falcon Heavy will be the ideal option. Although there is the constraint of the fairing space and area available, but still it's the most powerful rocket. And
Okay.
over that, it's reusable. And so if Falcon Heavy had been made non-reusable, it would cost a lot more than what it actually costs right now. Currently, the cost of launching a payload on Falcon Heavy is $90 million. But if it wouldn't have been reusable, it would be about 150 to $200 million. So
Okay, that's almost
reusability
twice
is
the
one of the
price.
prime factor of Falcon Heavy. It hasn't been tried
Hmm.
before, but SpaceX has been successful doing it for single boosters. So it said, why not three boosters at all at one go?
It's quite cool. Yeah, because actually Falcon Heavy there, like SpaceX has been making progressively, like they have been performing really well in the field of aerospace and rocketry.
Yes,
So
they are
yeah,
crazy
that
people. They launched Elon
yeah,
Musk launched his own car into space for the testing phase of Falcon Heavy. Actually, they're expected to
yeah,
launch concrete blocks or something, some fake dummy payload. But why not a car?
nice. Yeah, that way they also go for the publicity of Tesla.
Yes, smart minds.
All right, yeah, exactly. So Abhishek, what about your favorite launch vehicle?
My favorite launch vehicle is Saturn V.
Hmm.
The main reason that it is my favorite is that it created history basically. So it sent the
Hmm.
first men on the moon, and it was way ahead of its time. Like even if after knowing many principles and many subsystems, if I look at how the subsystems in the Saturn V work, I wouldn't understand some terms like. They used many advanced technology in that. It was way ahead of its time. That even today I couldn't understand that what they were using actually, and of course the roar it made while launching. So it was,
Yeah.
yeah, it is like I cannot explain that thing.
Actually, like it's still said that Saturn V was such a big rocket, but still on the computers which led the humanity to the moon were actually very much very less powerful as compared to what we have today in the smartphones, those computers.
Yeah,
Right.
yeah, yeah. They
So
had a
like I
memory
would say
about
like
some few
humanity has
kilobytes.
come a long far. Yeah, exactly. Hmm. And Sandeep, your launch vehicle.
According to me, it will be unfair to just name one specific launch vehicle because I personally have a attraction towards many of them, including
Hmm.
mentioned by Ajay Falcon 9, because it is a technology which was never imagined and which was never tested by anyone in the entire history of the
Yeah.
space science. So that is my uh, personal, what we call it as a
View on.
personal love for that rocket. But
Okay.
apart from that, I like other rockets also, like Relativity Space has all 3D printed its rocket. So that is
Hmm.
also a very awesome stepping stone in the space industry. And the launcher one is also launched on Boeing Boeing 787. So that is also a great milestone. So uh, it's very hard to judge favorite.
Okay. So like when I was going through the questions that I'm asking you, right? Like I came and thought about my favorite launch vehicle. It turns out to be N1 rocket. It was developed by Roscosmos, right? And it was actually like it was really a big rocket. Like it was the Russian analog of Saturn V because even the Russians wanted to go to the moon. That's what space race was for, right? And rocket actually didn't go to the moon. It actually had four launches, and all of them failed. But still, like for few technological reasons that they had, it's still my favorite rocket because of the static thrust vectoring. People who don't know about static thrust vectoring are still joining us in the chat right now and spectating us. They can actually Google it, the N1 rocket. Right. All right. So we'll go to the next question. And okay, so if you are given the responsibility of a mission director, or you are assigned a rocket team and now you have to develop a rocket, so what chronology will you follow while designing a rocket? Let's start with Abhishek.
So first of all, we will look upon the problem statement, that what kind of payload we have to launch, whether it is a human, whether it is a big telescope, or whether it is a small sat. So we'll write down all the needs and all the requirements which the payload needs. Then we will design the propulsion system which will be needed to propel the particular payload. And then according to the propulsion system requirements and the payload requirements, we'll manufacture the body. So this will be my chronology for designing the rocket. And if we look the chronology of manufacturing, so we will go just the ulta of it. So first I will start manufacturing my fairing part, then the body tube, and then at last the propulsion part. So Sandeep, what according to you is the best chronology for designing and manufacturing?
So, according to me and according to my experience in the rocket science still yet or any aerospace domain, I believe there are five major steps in building any technology from scratch. So, first is RFP. We tell it as an in technical term request for proposal. Like in this, as Abhishek said, it is a study of the requirements that you want to fulfill by that rocket. And the second stage comes, we decide our design specifications, like what all options we have and which we need to select for this particular proposal. So that is known as a preliminary design review or a PDR, which you all know. And then after this, conceptual design is the main phase in which we start the designing our whole rocket from in softwares like CATIA, SolidWorks, AutoCAD, or whatever it is. So, and after conceptual design, there comes a stage where we start to manufacture our rockets. Rockets manufacturing include development and testing. So, after this manufacturing stage, there is a very crucial stage which is very important to in any reputed organization or in, like SpaceX or ISRO or whatever agency it is. It is validation. Validation includes quality and standards of the component used and like casing used to if the rocket is going to sustain that excessive temperature or something. So it is like a mill standard or something. After that, at last, there is a final launch. So these are the total five stages which are necessary in any technology design, or you can name it as space also. So this is my personal view regarding this.
So we have Deepak over here again.
Yes.
Deepak, can you hear us?
Audio.
Deepak, your audio is not audible.
I'll share my perspective on this on
Yeah.
this question. So, if I was supposed to be a mission director for a team, for personally, I would think that I would keep the people working for the rocket above the rocket itself. So, they are the ones that matter. So, the primary task will be to delegate work accordingly and to form proper teams as per the manpower required, and then proceed on to start building the rocket after thorough planning. So, basically, that's all what we need. I think you guys described how to build a rocket pretty well. So this was the only point I wanted to add in.
Okay. So, we have been in this society, we have been listening about this term. Like, all right, so it's not really rocket science, right? So this term, like rocket science, can you just uh, justify like why rocket science exactly not the rocket science that we call it? Like, let's start with Sandeep.
Uh, Rocket science is not exactly a rocket science because in earlier time, what happened? The rocket science exposure wasn't much, and the people were not knowing what is exactly the this field, what does it do, and how it will help the economy of a country, and what impact it will have in the upcoming centuries. So now the space education is increasing rapidly, and the infrastructure is developing in our country also. So apart from that, like many developed nations like USA, Europe, and all are launching student satellites in the space. So now access to the resources and access to the education and the access to the infrastructure has reached rapidly to the students. So it is not rocket science anymore. Like it was previously a taboo that rocket science is a very hard or complex field, which can't be done by any specific individual. So that is my view on
Hmm.
this.
And Jay?
Okay, so it's as Sandeep said, the phrase "it's rocket science" has been overhyped since quite a few years now. Like people who find something difficult just coin this phrase, just put forward this phrase, and it's rocket science. I can't do it. But in actual terms, it's like a superstition. Like Kali Billy, if a black cat runs in front of you, you shouldn't cross the road. It's something like that because it's not the actual it's the statement is not based on facts. And I personally believe, and this feeling was reinforced after I worked for Star Labs, that building a rocket is not actually that tough as people imagine it to be. And so we should like remove this phrase from our dictionary that it's rocket science. Uh, it is tough, of course, but
Yeah.
like if you approach it step by step and properly, it's not something impossible. Look around you, like it's happening
Yeah.
everywhere. So that's my point.
Yeah. And Abhishek, what are your views on rocket science not actually being the rocket science?
So the first rocket which I made was a single stage quadruple engine rocket. It sounds complicated,
Okay.
right? But it was just basically four Diwali rockets attached to a plastic bottle. So you see
Okay.
how people complicate things by saying technical terms. So in rocket science, the same thing is happening with rocket science. People are complicating it much more than it actually is. So it's nothing, just a simple thing which is taking off like this and nothing else. But people are
Hmm.
hyping it, overhyping it, as Jai said. So yeah.
Okay. So, all right. And yeah, since we have been talking about the many other the rocket companies like SpaceX, then Lockheed, Boeing coming together and making ULA, and many other Rocket Lab and Electron Rocket, these kind of companies. Like, so, what do you think? Like the major problem is like what are the challenges faced by the rocket companies when they are trying to establish themselves? So, let's hear it from Jay.
Okay, so when rocket companies are trying to establish themselves, the primary barrier they face is funding. So if you have I was talking to
Hmm.
one of my juniors yesterday, and this was a point that came up that many people in the world have funding, and many people in the world have passion and vision, but it's very rare that people have passion and vision as well as money all together in once. So that's where the problem arises. Like if you should have enough funding, enough backing for establishing a rocket company, because it's very difficult process, and there's a lot of patience involved in this. You cannot just make a rocket overnight and launch it into space or get government contracts for it. So that's what happened with SpaceX story. They took years to develop the rocket. They also had a
Hmm.
prototype rocket, which Falcon 1, I guess. I guess you all
Yes.
have heard about it. So Falcon was one is
Hmm.
actually successful in its fourth try, but it was a stepping stone to build Falcon 9 and further rockets, which were extremely successful just because of the lessons they learned from Falcon 1. So that is one of the primary barriers. Other barriers involve government restrictions. Uh, they are barriers, but they are necessary barriers because government also needs to safeguard their military interests and other policies that might harm citizens. So, uh, space companies should try to adjust themselves accordingly and grow in the correct vector. Those are the major problems that are faced by space companies currently.
Okay. All right. And like, what are your views on this, Abhishek?
So again, the funding is the major issue which any rocket company would face, because space is a very costly business. I am not demeaning anyone, but if you open or start any app, okay, so consider that you suffered a failure. So that doesn't mean that you will suffer major financial loss, okay? Because it's basically an app, okay? So your code needs to run. But in rockets, if your rocket launch fails, many other things fail as well. The rocket launch fails. The rocket fails. The satellite or the payload which is installed in the
Yeah.
rocket, even that, even we lose the satellite or the payload part, electronic subsystem and whatnot systems fail. So it is a very costly failure. So for opening a rocketry business, one needs to have huge sum of money with them, and
Okay.
he or she should be ready to face the failure, because rockets do not we do not get a successful launch, or it is not 100% surety that your rocket will succeed at one go, because thousands and ten
Exactly.
thousands of things 10,000s of things are working simultaneously, and 10,000s of things need to work perfectly all at once. So you get the odds.
Exactly.
Yeah. And other thing is the passion, actually.
I mean, data center to have.
As we know the story of SpaceX, they took almost 12 to 15 years to get a successful launch. So and they suffered three major catastrophic failures. So had they been
Yeah.
lost their interest, or they gave up after the first failure or second failure, we wouldn't have watched Falcon Heavy
Yeah.
launch. Yeah. So yeah, that's all.
Exactly. Okay, since you all have particularly worked on rocketry and very specifically on some systems of the rocket, Jay, I would like to get the answer from for the question from you. Like, can you tell me about the logic or the algorithm which is used in the launch controller, like your wireless ignition circuit?
Yes, sure. So basically, in any launch controller, I would talk specifically about what I did when I was entering for Star later on. But a launch controller is a very important part of a rocket system. Yeah, even though it is associated with the ground control system, and it's the thing that puts
Hmm.
your rocket into space. It starts the engine fire, and that's what we need.
Hmm.
So basically, we were working for the Star Excel project in at Star, and we needed a wireless ignition circuit for that because of safety issues. Earlier, we just used a long strip of wire and induced a current in the
Yeah,
at the other end using batteries to launch the rocket. But that was not safe at all. In case
exactly.
the rocket misfired or the booster left the stand, so what I designed was it was a very simple concept. I took Arduino Uno board and using that as the primary controller, I attached a 12-volt battery, which will be the primary power source to it, and a relay circuit
Hmm.
that could switch on and switch off whenever I give the command from my phone or any device that can connect with the Arduino through Bluetooth. So to enable the Bluetooth feature in Arduino, there is something called a Bluetooth module for Arduino that comes separately. So you basically what you need to
Hmm.
do is integrate the Bluetooth as well as the relay with the Arduino board, and make it into a compact box that is totally independent
Hmm.
with the battery. So it's a standalone unit. So what actually happens during the launch day is
Okay.
there's an application provided for connecting the Bluetooth module of the Arduino with your phone. So as soon as I press the switch on button, the Bluetooth module gets the command and sends it to the relay via the Arduino, and the relay switches itself on, and the current from the 12-volt battery is allowed to pass to the long strip of wire to the booster, which will set the booster off. So it's very simple, but the essential part here is the safety involved. Like you can switch it on from meters away,
Okay.
and everybody is quite safe.
Yeah.
That's the only purpose I designed this
Okay.
ignition circuit.
All right. It's quite good. So, Abhishek, my next question is for you. Like we all know that in a high-powered rocket, like as my work experience says, I've always used the solid propellant rockets, right? So, apart from this, like, is there any other possibility of using some other propulsion systems, or if you could just explain the solid rocket boosters in brief about the
Uh,
system that we use on the HPR.
so HPR, the full form of HPR. First, let me start off with the full form of HPR. It's high powered
Hmm.
rocketry. So high powered rocketry,
Yeah.
in the name it suggests that it consists of very high power. It produces very high power, and we need high power for getting much higher altitude. Okay. So
Okay.
the different types of power are classified into different class of motors. So if I talk
All
about
right.
class A
Hmm.
motor, then it consists of, let's say, 1.23 Newton second specific impulse, and for getting and for using a propulsion system in high powered rocket, we need a rocket motor of H class, which has a specific impulse of
Okay.
almost 160 Newton seconds. So
Hmm.
if we compare it with Diwali rockets have only 0.3 to 2.5 Newton second specific impulse. So imagine how strong or how powerful the H class motor might be. That means
Yeah. Yeah. Exactly.
it's almost 80 times the power which a Diwali rocket holds. So
Yes.
Hmm.
I was talking about the solid motors, okay, which contain solid propellant. So in solid propellant we have both oxidizers and the solid fuel and the fuel mixed together, and we burn and combustion takes place. The fumes come out of the nozzle and we get thrust. So this is how solid propellant motor works. Uh, if not solid propellant, we can the major disadvantage of solid propellant is that we cannot control the thrust, the amount of thrust which we want. So
Hmm.
if you want to control the thrust, we can use hybrid propellants as well. In hybrid propellant, one
Exactly.
oxidizer might be any fluid, and the propellant would be a solid. So it is a mixture of liquid propellant and a solid propellant. So I myself have worked on hybrid propellant. We used liquid oxygen as
Okay.
propellant and the candy wax as the fuel. So
Okay.
what happens in that the liquid oxygen is passed through a small hole. The hole uh, the hole
Hmm.
is surrounded by the fuel. So this is how the contact between
Okay.
the liquid oxidizer and the solid propellant takes place. And we ignite it by using a spark plug. And after ignition, we can control
Hmm.
the amount of liquid oxygen which is flowing through. If we want high thrust, we can control the valve uh, from which the liquid oxygen is flowing, and by increasing and decreasing the amount of liquid oxygen flow, we can control the thrust. So we can use these two systems in high powered rocketry.
Okay. So I would say Sandeep is well in time here, so he just didn't miss his chance. Right. So Sandeep, can you just tell me about the logics and the algorithms that were used for the avionics to activate the recovery system?
Yeah, sure. So I will wrap up it in just a brief thing because I took already some time. So according to my knowledge,
It's
I
fine.
have used three kinds of mechanisms for the activation of recovery system. First is altitude based recovery. uh, Altitude, you all
Okay.
knows that altitude can be defined by the pressure. So this is the most commonly used
Hmm.
method. And apart from this, the second method is
Okay.
airspeed based, in which what we do, the rocket goes vertically, and while taking a peek at the projectile, the drag
Hmm.
increases on the rocket. So we can use a flap switch on the body of the rocket, and it will trigger the electrical switch inside, and
Okay.
the ejection switch will be activated. And the third is GPS based GNC, guidance navigation and control system, in which we can use our inertial measurement unit sensors like magnetometers.
Okay.
You
Hmm.
all know that magnetometers are also used for defining the location of any object on the Earth. Like there are magnetic coordinates of each and every place. So these three methods can be used for activating the recovery mechanism. And the recovery mechanism itself includes like many ways, like pyro, using pyro, or using some cold gas to eject eject the nose cone of the rocket, and so these are the most two commonly
Yeah.
used.
Okay. I would like to just know about like having known the rockets so well. I would just ask you about the most complex and the most simplest part of a rocket or the subsystem of a rocket. So I would start with Abhishek.
According to me, the most complex part or the complex subsystem is the propulsion system, because there are many complex parts actually, which are fit into a simple or a, there are many parts which are fit into a simple small into a small volume. So basically, due to the space constraint, the propulsion system is the complex subsystem for me. And the most simple subsystem which I feel is the fairing separation system, that is actuated by the solid thrusters over there.
Okay. And Jay?
Okay, so I don't think there is anything such as a simplest subsystem of a rocket. Everything is pretty sophisticated and needs to work exactly as planned. But yes, as said by
Yeah.
Abhishek, yes, fairing separation is pretty basic and doesn't require like as much effort as other subsystems involved. So basically, there are two very complex
Hmm.
subsystems involved in a rocket. One is the propulsion system, as Abhishek told. The engines have a lot of valves and pumps involved, and if any single one
Pumps.
valve of it malfunctions or anything happens to it, it gets jammed. Then the mission is over. Basically,
Yeah.
the launch vectoring can't be done properly, and the thrust will be totally haywire. It will not be under control, and that's the coming to the
Hmm.
second most important subsystem. It's control. Basically, you should have control over your rocket during flight and
Yeah.
during the entire mission. So controlling the rocket during its flight
Exactly.
is very important. Also, this also relates to the Falcon 9 reusability, where it's coming down. I'm working on a paper over it, that the reusable systems of Falcon 9. So there are
Hmm.
basically three things that control the re-entry flight. One is the cold gas thrusters, cold nitrogen gas thrusters, that
Yeah.
are
Hmm.
also known as attitude thrusters, basically, and they are used to adjust the downward trajectory of the rocket. Second one is very innovative and never used before. I don't think so. It has been used before. They are the grid fins. Now,
Yeah.
SpaceX
Hmm.
figured out that when the rocket is falling downwards, there's a lot of airstream flow going around its body, and they can use
Hmm.
this airstream flow and direct it towards another direction to steer the rocket. So
Okay.
that's a very efficient control system. And the most important one is the engine itself. When anything is falling down from space, it needs to decelerate very quickly and
Exactly.
control its flight. Yes. So again brings us to the propulsion system. So I think we can all agree on that propulsion system and engines are the most complex part of the entire rocket.
Okay. And Sandeep?
What I believe is we can't define any most complex or simple component or subsystem in a rocket. It depends from person to person. If a person is a propulsion engineer, he might be knowing about, he might be telling about the propulsion system is the most complex system. And as being a avionics engineer, I will say that the telemetry system is a most complex system in a aircraft,
Okay.
because aircraft or a rocket or a space vehicle, because if telemetry is
Hmm.
not there, you don't know where the rocket is going. It is like a flying bomb or a missile which can go anywhere.
Yeah.
And it is unguided. So that is the thing. I believe that the
Exactly.
telemetry system is the most important component in the phase of rocket development.
All right. All right. So I see that more or less all the questions have been covered. I'll move on to the questions that we received on the social media platforms, but just after these questions. So, briefly, I would just like to know about your experience in rocketry. Like, how was your experience working on rockets? So, Jay, again, we have heard from you the last time, but you'll get the you'll get the chance in the last. So, I'd like to start with Abhishek.
So as I told, my first rocket was a single stage quadruple engine rocket. That was
Hmm.
nothing but four Diwali rockets attached to the bottom of a plastic bottle. So I ignited those engines, but I couldn't ignite them all at once. So first I ignited the first engine, second engine, and by the time
Yeah.
I tried to ignite the third one, the other two went off, and the rocket did a
Yeah.
360-degree flip. So that was my first rocket,
Nice.
and so I guess we all have started like that only.
Yeah.
Then I
Okay.
so this was done without research work, without any research work. Then I thought that this is very dangerous. So I searched on YouTube that how propellants are made.
Hmm.
Then I came to know about KNO3 motors, commonly known as sugar candy rockets.
Yeah.
So I tried making one at my home, but again I failed. Means while making it, I the temperature was not like the temperature was more than it was needed. So the propellant which
Okay.
I was
Hmm.
cooking, so that burned in the pan itself, and it was very dangerous. So I never tried that again.
Yeah.
Then I went to Star Labs. At Star Labs, they taught me how to do it properly. So the first propellant which I made was at Star Labs, and the first rocket which I launched was at Star Labs. Then I moved towards the hybrid propulsion thing. We did this project in our college itself. So Team Radian, as I told, so
Okay.
this team works on solely on rocket technologies. We even 3D printed our rocket, and we were working on this hybrid rocket engine in which we use liquid oxygen as an oxidizer, and candle wax as the fuel. So that was my experience on rockets. What about you, Sandeep? Uh,
Sandeep, audio.
Sandeep, we can't hear you.
So, okay, now you can hear.
Yeah, yeah.
Yes, audio.
So my first experience with the rocket was in year 2017 when I took part in a competition named as CanSat, and our college team was named as Team Astral, which went to USA for this annual CanSat competition in Texas, Stephenville. And my role in that team was that I was an avionics engineer responsible for designing the electronics of the rocket, and apart from that, I was responsible for the telemetry system of the rocket. After that, after a gap of 1 year, while I was doing my internship in year 2018, I collaborated with a group of enthusiasts from state of Kuwait. So after a hard work of near about 2 years, we have finally developed 100 kilometers of orbital rocket which is going to be launched in upcoming few months in Kuwait itself after the lockdown. So and after that, I did my internship at Star Labs Surat. So that was my third experience with the rocket. So this is all.
Okay. And Jay?
Okay, I think we almost covered all of the points in last webinar, but for our new audience here today, I'll take it from the start. So, rockets are basically what I wanted to build my career around since my childhood, basically, and I never like changed my mind about it. So, I had started making very precise plans to if I ever get the chance to make a rocket, how will I do it? What kind of fuel will I use? What kind of rocket body will I assemble? What kind of material will I need? But I was never actually able to start it. But later on in my eighth grade, one of my teachers was very instrumental in encouraging me through this process, and made my first rocket in my eighth grade. My experience was bit
Oh,
similar to that of Abhishek's. I used Diwali rocket boosters because initially I didn't want to test with homemade fuel. So I did try it. It was successful a couple of times, but not too much. And quickly shifted to making my own fuel. So I used to take everything very proper in procedure and stepwise. So I started with making fuel and testing it, doing a solid fuel test on the ground itself. It failed a couple of times, but finally I noted down points and I was able to know how much do I need to cook the fuel, what kind of color would I achieve when I would know that the fuel is ready, and how do I actually put it into the booster without any difficulties or any fuel being wasted. So after I perfected that, I made my first rocket. I named it Sirius after my favorite star, and uh, I launched it on, I think it was August, and I launched it and basically failed as expected. But I had high hopes on it. On later analysis, I found out that the problem was there was some air gaps left in the fuel, which is a major disaster. Whenever you make
Yeah.
make fuel candy, you do not leave air holes or air gaps inside the fuel. So this was my first experience. It went on and on. I made quite a lot of rockets later on in my life till the 12th grade, and I was very lucky that the police didn't show up at my house asking that what I'm doing, because actually it's illegal. Whoever is listening in out there, please know that it's illegal to launch any rocket beyond 100 meters without police permission and permission from the nearest ATC, air traffic controller. So then came college. I realized all this. I tried to set up a projects team, but it was not possible because of lack of funding and general issues. And then came Star Labs came in my life like an angel, because they provided me the platform to do exactly what I wanted after so many years, after almost 3 years of living without rockets, and it was the best experience of my life till date. So that's my experience with rockets till now.
Okay, so people who are listening to our panelists right now, it's my humble request to all of you. Please do not make propellants inside the room, right? Instead, first do a lot of homework and research, and then please proceed outwards. If you make outward, if you make your propellant out of your room, it would be better. And please make sure that you don't just get caught planting rockets. All right, so we are out of questions, and now we'll be switching on to the questions that we received on the social platform. So it won't take a lot of time, a lot of time, right? So a basic question was asked, was DM to me on Instagram, like the difference between a rocket engine and a jet engine. So that's quite a simple question, but I'd like Abhishek to help us there.
Yeah. So I will show you a simple demonstration of how a simple combustion takes place. Okay. So I have a matchstick with me. I was prepared that this question would come. So as you can see, the black part, the tip of the matchstick is the fuel, and the air around me acts as an oxidizer. So as I start, the combustion takes place. The flames are coming out. So that means in the presence of an oxidizer and fuel, the combustion takes place. In jet engines, the oxidizer is the air coming inside the engine. So and in rockets are basically used for sending things into space. In space, there is no air, so they cannot use oxidizer as air, because in space we cannot get any air. So in rockets, we need to carry our own bag of oxidizer. That is mostly liquid oxygen is used as oxidizer. So this is the basic difference between a jet engine and a rocket engine. The jet engine uses oxidizer as air, and the rocket engine uses its own oxidizer.
So that's like more of a non-breathing engine and a breathing engine, air breathing engine, right?
Yeah, yeah, yeah,
Okay, like we all know about the Chandrayaan was the launch of Chandrayaan 2 was delayed, right? It was delayed by
yeah.
almost a week, but still somehow ISRO manages to reach the targeted position on time. So, what changes do you expect that scientists would have made to the entire rocket or the mission trajectory or the entire mission profile? Okay, Jay, what are your views on it?
Yes, okay. This has everything to do with orbital mechanics. And frankly telling, orbital mechanic engineers and scientists are the most well-paid people in any space organization, because everything depends on them. The entire mission depends on what
Yeah.
their output is. So, what if anything happens to a mission or a mission gets delayed? What they basically do is they already have alternatives prepared for it. So they use quite a few softwares. I worked on a few of them. NASA has also recently open sourced one of its orbital mechanics software through which it used to prepare orbits for its spacecrafts. So every single spacecraft has a set objective, and these people, orbital mechanic engineers, their task is to define multiple ways to reach there. Now this considers all the contingency plans, like if your rocket gets delayed, or if something happens during the orbit and the orbit maneuver is not possible, so what can we do to finish our objective? And the only variations that happen in this are fuel variations, as well as the thrust timing and duration variations. Those are the only stuff that they need to change. That's why it's a very difficult job to do. Like that's the only flexibility they get, but still they have to reach the objective somehow. So that's what ISRO did basically. ISRO might have had quite a few contingency plans ready. So they might for example, they might have changed the maneuvering angle, or they might have changed the fuel levels required, or the amount of fuel per thrust, maneuver thrust they are using. So there's a lot of things involved, and it's very complex. It's not very easy to
Yeah.
do this, but they did it. So always does what's expected of them.
Okay. So our next question is for Sandeep. Like, what do you think? Well, like, what's actually the role of 3D printing and AI in the field of rocketry?
Uh, uh, Giving example of relativity aerospace, which I was talking about earlier. So the
Hmm.
time, the time and resources can be saved a lot, and we know that in advancement in the technology of 3D printing, the whole rocket can be printed using less, consuming less time. And I will talk about the use of AI. Use artificial intelligence can be used in many decision making algorithms. All algorithms of the rocket, like many big rockets include a flight termination system. If a rocket goes outside a particular bounded area, so the controller itself triggers a mechanism which will destroy the rocket before going
Hmm.
into a public area. So at some places, in some countries, it is done by a Air Force official, like in USA, the FAA, Federal Authority of Aviation. It does it. Man controlling the whole launch is on the ground station, and he is on the switch. That if something happens, he will trigger it. But now with the advancement in the technology, the AI is coming into the picture, and now the whole process of flight termination system has been happening with the redundant microcontroller, which is placed inside the rocket. If primary thing fails, then also the one will work. So it is all due to the artificial intelligence in the space science. So that
Okay.
I believe.
All right. So now, like, few questions that we got while we were live. There's one question from Savaya Ishant. He asks, what type of fuel is the most efficient? I guess he might be talking here about the solid,
Rocket
liquid, and
purpose.
the, yeah, like the different type of propellants that we have. So Abhishek, I would like you to answer this question.
So any fuel which has a higher specific impulse acts as the mileage of a rocket. So
Yeah.
in bikes, if we have more mileage, then we consider it as a better bike, better fuel. Okay. So in a similar way, the fuel which is having higher specific impulse is more efficient fuel according to me.
Okay. Yeah, because that's what goes by the definition of specific impulse, right? The amount of momentum that is being imparted to the space vehicle for every margin of the propellant that's being consumed, right? So
Yeah,
I guess
that's correct.
higher specific impulse is absolutely like the one of the criteria that you should be using to categorize the efficiency of fuel. But again, you shouldn't be if thrust comes into the play, then in that case, this whole criteria tends to fail a bit, because nuclear rockets, they tend to have a large specific impulse, but they don't give enough thrust, right?
Enough thrust. Yeah.
So depending upon the situation or the requirement, it should be okay. And all right, fine. So let's look at the next question. So there are a few questions. There's a question by Madhu. How is the scope for space enthusiasts in India, and what could be the best way? What could be the ways one could kickstart a career in the same? Madhu, I would suggest you to go through the Star Insights YouTube channel. We have uploaded the webinar over there, so you'll get to know more about it. And okay, apart from this, I guess, yeah, there is an interesting question here by Piyush. This question is for you, Sandeep. What communication modules are used for telemetry and for feedback of crucial functionality of a rocket? And what communication modules are the most reliable?
Can you repeat again question?
Yeah, what communication modules are used for the telemetry and for feedbacks of crucial functionality of a rocket? Apart from this, could you name some reliable communication modules?
Okay, so I will start this answer with going into some frequency thing. So in rockets, what do we need? There is only a telemetry which consumes very less data. So we need more distance and not the data rate. So what do? We
Hmm.
use lower frequencies like 933 megahertz frequencies for communication in rockets because we all know that as distance increases, we need to use the lower frequency. And if we need to go for the higher data rates, we use a frequency like 2.4 gigahertz, 5 gigahertz frequency bands. But as a note, I will also tell that there are some frequency bands which are licensed band, which are not to be used by public, and there are some bands which are strictly for the use of military and space. So telling about some communication modules, there are a lot in the industry communication modules. I will name some of them. Like Silvus Technologies is a company which recently announced that they have tested their own 100 kilometers radio at a frequency of 2.4 gigahertz. It is a great achievement because in this 2.4 gigahertz frequency at a data rate of 4 mbps, they are transmitting the telemetry and the video both. So these space agencies are making their own telemetry modules. There are no like OEM products for the long range space vehicles like that go up to the LEO or GEO orbits. So I can't specifically name such kind of products for 200 kilometers or 300 kilometers range as of now. So this is all playing with the frequency thing. So if you want to know more, you can DM me. As due to time restriction, I can explain on a limited scale only.
Okay, so there is another question from Savaya Ishant. Is asking about how can you apply orbital mechanics. So, brother, I would just suggest you to go through Kerbal Space Program tutorials. They'll help you out a lot.
Yes.
That being said, like actually, orbital mechanics are they form the very basis of the entire space program, right? Because you have to get into an orbit, then you have to perform multiple maneuvers, and then that's going to help you get to the final orbit or the final target approach, right?
Yes.
Um,
Also,
all
like
right.
if you want to
And
know more about orbital mechanics, you start right from the Kepler's laws of motion, orbital laws.
exactly.
Yes.
And Deepak, I would like to also add a point to the question asked by Piyush, that in
Hmm.
every system in which telemetry is important, the data coming from the aircraft or our rocket is very important.
Yes.
Instead of the data we are sending, the data rate of like reception gain should be more. When we decide an antenna for a system or a radio, the reception gain of the ground antenna matters the most. In rocket technology or in any aircrafts, there is a new technology named as conformer antennas. These are the
Hmm.
antennas which can be mounted on the surface of the rocket itself, to have more area and more signal reception at the rocket end. So this can help.
Okay, so there is one another interesting question by Madhu. He says, why have scientists been leaving ISRO and are striving to build a startup in space tech? Anything people miss to know? Like, I guess she's actually trying to ask about why basically people leave ISRO and is something like inside ISRO that we are not knowing about. So I don't know, like if anyone would like to take this question.
Sure. Like
I guess it's
yes. Abhishek,
yeah.
continue.
Okay.
So I guess it's actually it depends on people's expectations. If I expect something from an organization, and if that organization is not fulfilling my expectation, I'll leave that organization. So if people are leaving ISRO, that's because of the personal expectations. Basically, there is nothing, uh, anything in general, any reason in general that why people are leaving. It's because of the personal expectations which are not being fulfilled, and they think that
Okay.
they will learn more if they build a startup of their own.
Okay. So actually, Ishant Savai was actually asking about the job in orbital mechanics. So, Jeb, like, how would you help him here? Like, if particularly wants to be a person working on orbital mechanics.
Person working on orbital mechanics. Okay. There are very few courses in India specifically who specialize in this area. But if you can get into them, then sure, like you can always become a orbital mechanic person. And I think if you want to get a picture of what the work is, I would recommend you to watch the movie Martian, where they very beautifully demonstrate how the job is significant in the mission itself. Like I don't know if I can refer
Yeah.
to it, but I'll not spoil it for you guys. When Mark Watney fails to come back to the space station, the orbital mechanics people basically design a new orbit for the station to come back and get Mark
Yeah.
Watney on the spacecraft. I will not spoil it further. Just watch the movie, please. And if in
Okay.
India, it's I know it's difficult to get into this specialization degree and know more about it. But for that, I would recommend you guys to use open source softwares. Try to learn them more, and there are also courses provided by MIT. Guys, check it out, ocw.mit.edu, where you can get specific courses that are taught in such highly reputed colleges available online with all the coursework and the material and the assignments readily available. So you can use such resources to know more about this field. It's a very beautiful concept, basically, orbital mechanics.
Okay. Yeah, Jay, you wanted to speak something about the whole ISRO thing, like how why scientists are leaving. Like, could you
Yes,
help us get an
I don't
insight to
know.
that?
I want some examples from Madhu, like which ISRO scientist has actually left and started doing a startup. Because generally in India, people working for ISRO have a very comfortable job, and they also get pension if they don't leave and retire properly. So I don't think that people will leave ISRO and start working for space startups. But ideally, this situation is quite common in other countries because space startups are much more dynamic than government agencies, and
Okay.
because there's a lot of constraints that space startup face, and they have a lot of challenges to solve. So if I ever wanted to become a space engineer, I would start working for a startup instead of a government agency, because it will always keep me active, keep me on my feet, and present me with very difficult, almost impossible challenges that I will have to solve. And yes, in India also, I think many space startups have retired ISRO engineers, not people who have left ISRO, and they
Okay.
are very essential to establish the how the company should function basically, and adhere to the space laws of India.
All right. And there is another question by Ankit Jaiswal. Can we use electric propulsion in order to go to space? So,
Yeah.
Abhishek, yes.
So actually, in electric propulsion, we can, electric propulsion is basically we do not get enough thrust out of that. If we want to use electricity, we can use it to drive the pumps, as the company Rocket Labs is doing. They are electrically driving the pumps, which has increased the efficiency of the propulsion cycle from 50% to 95%. 50% efficiencies of the gas
Okay.
generator cycles, and the 95%
Hmm.
efficiencies of the electrically driven pump cycles. So if we want to use electric propulsion, we can drive electric pumps through it to get a better efficiency.
But for getting into space, not an option because as Abhishek said, electric propulsion won't help you get enough thrust. Right. Although if you are in space, it can help you move in space a little bit, but
Maneuver.
still not an option to get into space directly. All right, so I guess we are all done with all the questions. We had amazing audience with us, and the people who asked questions. Thank you, people. Thank you, viewers, for joining in.
There is someone
And
who's asking me to repeat the website again. It's ocw.mit.edu, or you can just Google Open Courseware by MIT.
okay, yeah, MIT OCW, yeah. And
Yes.
people are still coming up with some questions. Madhu, again, these questions like what would be your advice to astronomy clubs in colleges? These kind of questions have already been answered in the previous webinar. So please refer to Star Insights YouTube channel. Your question will be very well answered over there. And I guess that's it. So guys, it was really fun having you all on board, and you guys actually have tackled all the questions really well. So it was really good to have you, right? So
Thank
thank
you.
you
Thank you
people
for
for
having me.
joining in. And just so I'll let all the viewers and people who are still joining us. I can see people dropping some questions in the comment box, right? I would like you to know that again, after 2 days, that would be, I guess, Tuesday or Wednesday, whatsoever. We'll be informing you about that. We'll be having another webinar session on satellite technology. So be ready with your questions. The panelists have got you covered, and we'll be back. We'll be meeting very soon on the same time after 2 days. Right? Thank you, guys.
Thank you, Deepak.
Thank you so much.
Thank you,
All right.
Deepak.
Hmm.